Hey guys, this is Mr. Kelly. I'm sorry I can't be with you today. This is a video for lesson 6.5. So first of all, start the warm-up, try the warm-up if you haven't already, then watch this video to get the solutions to warm-up, and then we'll do some notes together, and then the rest of the class is just working on their homework, okay, which is Delta 6.5. Okay, so hopefully you've tried the warm-up, let's go ahead and try it. So let's look at this first one. We're writing a function that represents the situation. So first one says, profits of 100,000 increase by 5,000 each year. So let's make a function for this. So it's increasing by 5,000 each year. First thing I'm going to ask is is this linear or is this exponential? So since it's just like a nominal amount, like a numerical value that we're increasing each time, this is going to be a linear function. Okay, so we would write this as f of t, or you can make this whatever you want it to be, equals 100,000 plus 5,000 t. Okay, so it's going to tell me every year in the future I'm going to increase by 5,000. Okay, not a percentage, but actually $5,000. Whereas, let's look at the b here. A school population of 120 decreases by 6% each year. Okay, so that 6% indicates that this is exponential, right? If we have a percentage increase or decrease, it's going to be exponential. So if you remember from last class, now your letters can be whatever you want it to be. I'm going to use p of t because p for population, right? T for time. We need our initial amount, which is 120, and we are decreasing. So we're going to be 1 minus our rate of decay. So it was 6% as a decimal. It's not 0.6, it's 0.06. So it'll be 1 minus 0.06 to the t. If we simplify that, that would be p of t equals 120 times 0.94 to the t. So this would be starting with 120 students, decreasing by 6% per year. Okay, all right. Now this is some review here. Rewrite the following with only positive exponents in their simplest form. So this is what we did in the first half of the unit. I'm bringing this back because the unit test is coming up, guys. We have 6.5 today, but next class is a review, and then the class after is your test. So I'm getting you kind of prepped for that. Okay, so let's rewrite the following with only positive exponents. Let's take a look here. So we are going to distribute or apply this exponent to these on the inside. So remember, there's a little imaginary 1 on that 2. So this would become 2 to the third x to the 6th over x to the negative 2. Okay. Then, using the law of exponents, since these have the same base, I can subtract, right? So I can write this as 2 to the third times x to the 6th minus negative 2. That would be 2 to the third x to the 8, and 2 to the third is 8, so we could write it as 8x to the 8. I'm going to run through that one more time in case you got lost. The first thing we did was apply that. This is a power to a power. We multiply. 3 times 1 is 3, 3 times 2 is 6. Then, the 2 to the third I can't do anything with. That's just going to become eventually an 8. But the x to the 6 over x to the negative 2, we subtract. You take the numerator, you subtract the denominator exponent. So 6 minus negative 2 is 8, which is how we get x to the 8. Let's do one more for practice. So here we have a product, or multiplication. So remember again that these guys over here have a little 1 and a little 1 here, okay? And here you kind of go with like terms, right? So 3 times 2 is 6. X to the 5th times x to the 1, we add them, that's x to the 6th. Y to the negative 2 times y to the 1, that's y to the negative 1. Then, to move this y to the negative 1 to the denominator, we write, with a positive exponent, we move it to the denominator. So 6x to the 6 over y. And that's your final answer. Okay? All right, so that's the warm-up. I hope that was familiar with you. I did give you some of these in your homework, just as a review, so you will get a chance to go over that again before our review day. Now let's take our notes. So we're on our last section, which is solving exponential equations. Go ahead and get your notes out and go to 6.5. 6.5, okay? Okay, so property of equality for exponential equations. So what you're about to do, you can sort of see problems here down below, is you're going to solve equations with exponentials in them. And to solve them, we need to talk about the property of equality for exponential equations. I'm going to write it out first symbolically. So what the property states is that if we have two bases that are the same, right? So b and b here, they're the same base, and they equal each other, then their powers must also equal each other, okay? There is like an exception to this, where b must be positive, and b cannot equal 1. Okay, so b must be positive, b must be greater than 0, and b cannot equal 1. But if b to the x equals b to the y, then x must equal y. Okay, so if we have the same base on either side, and they equal each other, then their exponents or powers must equal each other. Okay? All right, so let's do some practice here. So we have some kind of relatively easy ones here. These all have the same bases, right? So 3 and 3, 6 and 6, 10 and 10. So because the bases are the same, therefore their exponents must be the same. Okay? So here, x plus 1 must equal 5. So we can subtract 1, x must equal 4. If x equals 4, these are the same. Okay? Here, remember that 6 is really to the power of 1 right here. So 1 equals 2x minus 3. We would add 3 to both sides. We get 4 equals 2x. We would then divide both sides by 2, so 2 would equal x. Okay? Last one. Again, 3x and 2x plus 3, they must be equal because the bases are the same. 3x equals 2x plus 3, or minus 2x both sides, so x equals 3. Okay, so the long and short of it is, as long as the bases are the same on both sides of the equation, and that's all we're looking at, then the exponents must also be the same. Okay? Let's do a little more practice here. So now we've got some more challenging problems, and this is what you're going to get in your homework. So you're going to have to solve equations with unlike bases. To solve exponential equations, you must first rewrite each side of the equation using the same base. So see here, we have 5 to the x on 125. I cannot say that x equals 1, right? Remember there's an imaginary 1 here? I can't do that because they're not the same base. 5 doesn't match 125. Same thing here, 4 does not match 2, 9 does not match 27. We have to make these equal each other. The bases equal each other. Okay, so this needs to be 5, and this needs to be 5. That needs to be 2, that needs to be 2, that needs to be 3, that needs to be 3. We'll get to those in a second. Let's start over here. So if this is 5, let's see if we can make this 5 also. So remember that 125, you may remember, is the same as 5 cubed. Right? So we can actually rewrite 125 as 5 cubed, because these are the same thing, right? 5 cubed is 125. Therefore, x equals 3. Okay, got that? So what we did there is we looked at both the numbers, and we kind of looked at it like, okay, well that's a 5, that's a 125. Well 125, I could kind of write that as a 5 to a power of something. And that's what we did, and therefore our bases got to be the same, therefore our exponents are the same. So that's what you want to do. You want to look at the two numbers, and I'm telling you, like, all the problems you'll get will be this way. You'll always be able to write them as the same number base, and in general you want to look at the smaller one first and see if you can make the other one be the smaller one. Let's take a look at the next one here. So we got 2, and then we got 4. Okay, well, 4, could we write that as 2 to the power of something? Yeah, we could, right? 4 is 2 squared. So this is 2 squared to the x equals 2 to the x minus 3, because 4 equals 2 squared. All I did there was substitute that 2 squared in for 4. So I have 2 to the x equals 2 to the x minus 3. What do I have to do with the power to a power? I have to multiply. So it's going to be 2 to the 2x equals 2 to the x minus 3. Therefore, 2x equals x minus 3. And I'll subtract x both sides. So x would equal negative 3. Okay? Last one here. So 9 to the x plus 2 and 27 to the x. Here's a little bit of a different situation. Now, I can't get 27 to be in terms of 9, right? If you think about 9, you can use your calculator to help you, right? 9 squared is 81, right? 9 to the first is 9, right? Like, there's no 27 there. So I can write the left one is in terms of 9, but I can't write 27 in terms of 9. But I could write this in terms of 3 and 3. Okay, but so for example, 3 squared is 9 and 3 to the third is 27. Okay, so what I'm going to do is change both of these. This is, so 9 is 3 squared, 27 is 3 cubed. So let's rewrite it. 3 squared to the x plus 2 equals 3 to the third to the x. Then I'll distribute, so it'll be 3 to the 2x plus 4 equals 3 to the 3x. Now that the bases are the same, I can write it as 2x plus 4 equals 3x, subtract 2x both sides, 4 equals x. Okay, and then if I took that 4 and I plugged it back into the original here, I would get the same answer, right? 9 to the 6 equals 27 to the 4. Like, I can check that on my calculator. That's a good step to do. 9 to the 6, 5, 3, 1, 4, 4, 1, 27 to the 4, 5, 3, 1, 4, 4, 1. So it works. Okay? Okay, this is all we're learning today, right? So I hope it's making sense. You've got to make the bases the same on both sides. To get the bases to be the same, you need to find a number that can be the base of both sides. Sometimes that number is already given to you. Sometimes both the numbers need to be changed. Sometimes only one needs to be changed. It depends. What you want to do is use your calculator, right? So either the for function or a scientific calculator. By playing around with this can help you find those roots, okay? Because you can just test, okay, well, what's 2 to the second, 2 to the third, right, etc. Let's try, we got one last example here, one last kind of variant of questions. So here, we got a fraction, 1/2. And we got a fraction over here, 1 over 64. So how do we deal with these? So when you see fractions, that indicates to you negative exponents. You remember, 1/2 we could write as 2 to the negative 1. Right, so when you see those fractions, you should think negative exponents. And 4 can be 2 squared. So really what I have here is 2 to the negative x equals 2 squared. Therefore, negative x equals 2. Therefore, when I divide both sides by negative 1, x equals negative 2. Okay? So again, when you see the fraction, you should think to yourself, negative exponent. So here, okay, well, I've got 4 and I got 1 over 64. So let's think about this. So what's 1 over 64? Well, that could be, let's see, 4 to the negative 3. Is that the same as 1 over 64? Those are the same thing. So I just tested this to the right to show you. But 4 to the negative 3 is the same as 1 over 64. Now you might be like, oh, how did you know that, Mr. Kelly? Well, I knew it because I'm familiar with like the perfect cubes and the perfect squares. Like I kind of can tell when those numbers are going to work. So how do you get good at it? You just have to practice and test. Like if you see a 4 here, chances are like this could probably work to the power of 4. Maybe it could. And if not 4, then you would try it like 2 to different powers here. Okay? So, and I'll show you 2 ways to do this one. So this one we would write as 4 to the x plus 1 equals 4 to the negative 3. And so you'd get x plus 1 equals negative 3 minus 1 both sides, x equals negative 4. Here's another way you could have done this. So it's also true that maybe you didn't get that that was 4, but it's also true that 1 over 64 is also 2 to the negative 6. Right? 2 to the negative 6 is also that. So what we could have done we could have written 4 as 2 squared to the x plus 1 equals 2 to the negative 6. So we would have gotten 2 to the 2x plus 2 equals 2 to the negative 6. So 2x plus 2 equals negative 6. 2x equals negative 8, right? Minus 2 both sides. Or x equals negative 4 divided by 2. So we got the same thing. Okay? So sometimes there's multiple ways to do them, like sometimes you can get the same base to work for both problems. So don't get discouraged, or don't think because somebody got 4 and you got 2 that you're wrong. But in general, I'll write this off to the side. When a base is a fraction, use a negative exponent. Okay. All right, let's do some practice. So I want you to try these problems by yourself first. If you're completely lost, okay, keep watching the video, but I'd love for you to just try these problems first and then watch the video to make sure you got it. Okay, all right, so I hope you've tried. Now let's do them. Let's go to the first problem. Notice how the bases are the same on both of them, so I don't need to do anything. It's just 9x equals 7x plus 8. Subtract 7x both sides. 2x equals 8. Divide by 2, divide by 2, x equals 4. Done. When the bases are the same, you don't need to do anything. Okay, the next one. This is 7, this is 49. Okay, 7, I'm gonna start with seeing, maybe I can write 49 in terms of 7, like with a base of 7. Can I do that? Well, yes I can, because I could test, well, 7 squared is 49. So I can write 7 to the x minus 5 equals 7 squared all to the x. I'm going to apply that x and get 7 to the x minus 5 equals 7 to the 2x. Therefore, x minus 5 equals 2x. Therefore, minus x both sides, negative 5 equals x. Okay, let me zoom out a little bit so you can see that. Okay, so again, bases were the same, straightforward, just set the exponents equal to each other. Base is different, you gotta change at least one of them to be the same as the other base. Okay, now we're on our last one. So we got 1/5 and 1/25. So it's gonna be hard, like I'm not gonna write the left one in terms of 1/25, and I'm not gonna write the right one in terms of 1/5. Because I wanna keep it straightforward, okay? I know that technically you could write this one as a base of 1/5, but we're not gonna do that. Instead, I'm gonna refer to what I said before and say, okay, well, when you see a fraction, you wanna think negative exponent. So 1/5, think negative exponent. What's that negative exponent? That's the same as 5 to the negative 1 to the x. In 1/25, we did that in an earlier problem. That's the same as 5 to the third. Okay, so we could rewrite this as just base 5. That'd be 5 to the negative x equals 5 to the third. Therefore, negative x equals 3 divided by negative 1 divided by negative 1. X equals negative 3. Okay, this is your homework, right? This is your homework, just doing these problems. You'll see it in the delta math, okay? One last thing I want to mention is on the delta math, you might see some big numbers, right? You might see a number like this, 7776. You're like, Mr. Kelly, I don't know like what base that is. That's when you kind of have to use your calculator, right? So you just got to test values, and you want to use like whatever other value it gives you. Maybe the other value is like 36, for example. And so that's when you're like, oh, like maybe 6 would work here. And so then you test, like 6 to the third. Okay, no, 6 to the fourth, 6 to the sixth, or 6 to the fifth. And that's how you get, for example, that 776 is really 6 to the fifth to the x, and 36 is 6 squared to the x plus 2. Okay, I'm just showing that as an example. So don't get scared when you see the big numbers. Use your other number to help you and just test. Like use your calculator to kind of guess and check. What does 6 work? Does 4 work? Test 6 different powers, test 4 different powers to find the one that works for you. Use your calculator. Feel free to use a graphing calculator from me, whatever you want to do, or use your for function, okay? All right, guys, good luck. work hard, and I will see you on Friday. See you tomorrow.